Welcome back to Business Statistics 207. Up until this point, we've covered procedures for collecting data, determining data measurement level, and describing the data using numerical measures. In business, we are constantly faced with the uncertainty in our decision making. If we always knew what the result of our decisions would be, our life as decision makers would be a lot less stressful. But in most instances, uncertainty exists. To deal with this uncertainty, we need to know how to incorporate probability concepts into the decision-making process. Chapter 4 takes the first step in teaching how to do this by introducing the basic concepts and rules of probability. You need to have a solid understanding of these basics before moving on to more practical probability applications that you will encounter in business. Here are the key learning outcomes for Chapter 4. After this series, you should understand the three approaches to assessing probabilities and apply the addition and multiplication rules. At the end, we'll cover Bayes' theorem for applications involving conditional probabilities. To begin, let's cover some terminology starting with what probability is. It is simply just the chance that a particular event will occur. The probability value will be in the range of 0 to 1. A value of 0 means the event will not occur, and a probability of 1 means the event will occur. Anything between 0 and 1 reflects the uncertainty of the event occurring. An experiment is a process that produces a single outcome whose result cannot be predicted with certainty. In business situations, the experiment can be things like an investment decision, a personnel decision, or a choice of warehouse location. To begin determining and assigning probabilities, we need to define the experiment to determine all outcomes that can result from a decision or an experiment. We call this the sample space. For example, the sample space by rolling a die is all 6 faces of a die. In a deck of cards, we would have 52 potential outcomes since we have 52 cards in a deck. One tool that is useful for depicting the sample space is a tree diagram. A tree diagram helps ensure no outcomes are omitted or repeated. In this example, we have 3 trials where each outcome can be a yes or a no. The experimental outcome for the 3 trials are listed on the far right. Suppose we apply the tree diagram in a financial context. We might be able to outperform or underperform the market. And in each instance, we might be able to outperform or underperform the market. And in each instance, we might be able to make gains or end up with no gains. Here we have a 42% chance that we'll outperform the market and have gains. This is determined by taking the 70% of the 60% chance of outperforming the market. Once we have defined the experiment and defined the sample space, we need to define the event of interest. A collection of all possible outcomes is called an event. We can have 3 types of events: mutually exclusive, independent, and dependent events. 2 events are mutually exclusive if the occurrence of one event precludes the occurrence of the other event. For example, if your Bloomberg assignment was turned in early, then it could not be turned in late, and vice versa. 2 events are independent if the occurrence of one event in no way influences the probability of the occurrence of the other event. And 2 events are dependent if the occurrence of one event impacts the probability of the other event occurring. Probability can be assigned to outcomes in more than one way. There are 3 common ways to assign probability to outcomes: classical probability assessment, relative frequency assessment, and subjective probability assessment. The first method of probability assessment involves classical probability. You're probably already familiar with the classical probability. It had its beginnings with games of chance and is still most often discussed in those terms. Consider an experiment of flipping a coin one time. There are 2 possible outcomes: heads and tails. Each of these is equally likely. Thus, using the classical assessment method, the probability of a head is the ratio of the number of ways a head can occur to the total number of ways an outcome can occur. The chance of a head occurring is 1 out of 2, or 0.50. The relative frequency assessment approach is based on actual observations. This method defines probability as the number of times an event occurs divided by the total number of times an experiment is performed in a large number of trials. And finally, subjective probability assessment is a method that defines probability of an event as reflecting a decision-maker's state of mind regarding the chances that the particular event will occur. When experience is not available, decision-makers must make a subjective probability assessment. A subjective probability is a measure of a personal conviction that an outcome will occur. Therefore, in this instance, probability represents a person's belief that an event will occur.